Pluto is not the world we once believed it to be. For almost a century, humanity treated it as something marginal, a tiny frozen object sitting at the far edge of the solar system. It was so small, so distant, and so faint that we even argued about whether it truly deserved to be called a planet. Then in 2006, that title was taken away. Pluto became the only world in the history of astronomy to be discovered, classified as a planet, and then officially downgraded by a vote. A name that once stood among the 9 planets of the solar system suddenly became a dwarf planet, almost like a footnote at the end of a science textbook. But then the James Webb Space Telescope turned its enormous golden eye toward Pluto. And what came back through that mirror was not something anyone was ready to receive. This is the story of what the most powerful telescope ever built discovered in that distant darkness. And it is also why Pluto may be more unsettling than almost any other discovery of this century. To understand why Webb's observations matter so much, we first have to understand what Pluto was once believed to be. Clyde Tombaugh discovered Pluto in 1930 at an observatory in Flagstaff, Arizona. He was only 24 years old at the time. He did not have a college degree. Night after night, he compared astronomical photographic plates, searching for one tiny point of light that moved against the fixed background of stars. When he finally found that moving point, the world gained its 9th planet, and a farm boy from Kansas carved his name into the sky. For the next 75 years, almost everything humanity knew about Pluto was guesswork. It was only a blurred dot of light, too small to see clearly and too far away to reach. We knew it was cold. We knew it was small. We knew its orbit was strange, tilted and stretched into a long ellipse, sometimes bringing it inside Neptune's orbit for about 2 decades before throwing it back out more than 4 billion miles from the Sun. Beyond that, Pluto was mostly just a name. A name printed on the solar system chart hanging at the back of an elementary school science classroom. Then, in July 2015, after 9.5 years traveling through space, the New Horizons spacecraft raced past Pluto at more than 30,000 miles per hour. And in roughly 10 minutes of closest approach, it changed everything. What it photographed was not the dead world many expected. On Pluto's surface was a heart, a massive bright region shaped almost like a Valentine heart, stretching about 1,000 miles across, slightly off-center, clean and bright against the surrounding terrain. They built models. They debated. They published papers. But they could not go back. The spacecraft had already traveled billions of miles beyond Pluto and was still speeding away. Anything it failed to capture during that one pass would never be seen again. Then came James Webb. Webb is not a flyby spacecraft. It does not take portraits the way New Horizons did. It reads fingerprints. Every wavelength of light that a world reflects or emits carries a chemical signature. And Webb was built to read those signatures with a precision no telescope in history had ever achieved. It does not need to travel to Pluto. It only needs to stare at the right tiny point of light from its position roughly 1 million miles from Earth and let the photons tell their story. In late 2022, Webb began doing exactly that. What it found is harder to describe than the images sent back by New Horizons, because Webb did not give us a clear picture. It gave us a list of molecules, a temperature map, and a series of patterns no one had expected. The first surprise was the haze. Pluto's atmosphere, despite being incredibly thin, is wrapped in layered hazes made of complex hydrocarbons. That much was already known. What we did not know was what those hazes were actually doing. In 2017, a planetary scientist named Hu Zhang at the University of California, Santa Cruz proposed an idea that sounded almost impossible. He argued that Pluto's haze was not warming the atmosphere the way haze does on Titan, Saturn's moon. Instead, he suggested that it was cooling the atmosphere. According to this idea, haze particles absorb sunlight and then radiate that energy away in the mid-infrared, dumping heat into space faster than the atmosphere can replace it. An international team led by Tanguy Bertrand used Webb's mid-infrared instrument to measure that effect directly. And the result showed that Pluto's haze really is pulling heat away from the dwarf planet. The atmosphere is being actively chilled by the very particles suspended within it. No other atmosphere in the solar system behaves like this. Pluto is cooling itself. and no one yet fully knows how to model what happens next. The second piece is chemistry. Sunlight, even the faint trickle that reaches the outer solar system, still strikes methane molecules in Pluto's upper atmosphere and breaks them apart. Those fragments recombine into heavier compounds, ethane, acetylene, ethylene, and many other hydrocarbons. They grow heavier as they drift downward toward the surface, eventually clumping into reddish-brown organic particles known as tholins. New Horizons detected some of these compounds during its flyby, but Webb has now resolved them in a level of detail no previous instrument could reach. Tholins are what give Pluto its color. They also belong to the same broad class of molecules that scientists believe may have rained out of Earth's early atmosphere and contributed to the chemical mixture from which life eventually emerged. On Pluto, they fall like a slow, silent snowfall lasting 4 billion years. They cover the surface with a layer of frozen organic chemistry. The sky over Pluto is dropping the raw ingredients of biology onto a world far too cold for any of them to truly act. It is the chemistry of life, frozen halfway through the process. The numbers behind that image are difficult to imagine. Sunlight on Pluto is about 1,000 times weaker than sunlight on Earth. Noon on Pluto is darker than the gloomiest overcast evening you have ever experienced on our planet. Surface temperatures range roughly from -387 to -369 degrees Fahrenheit. That is colder than any natural temperature ever measured on Earth by more than 250 degrees. The coldest temperature ever recorded at an Antarctic research station was around -128 degrees Fahrenheit. Pluto belongs to an entirely different category of cold. At those temperatures, the air you are breathing right now would freeze. Nitrogen, the gas that makes up most of Earth's atmosphere, would become snow on Pluto. Methane, the main ingredient of natural gas, would become a glacier. Carbon monoxide, a deadly gas at room temperature on Earth, would fall as crystals there. The chemistry of the air around us is the chemistry of Pluto's surface, but frozen solid. The third discovery is the one that feels the most disturbing. Pluto is leaking. Slowly, constantly, second after second, day after day, methane and other molecules rise from its fragile atmosphere, escape its weak gravity, and vanish into space. Scientists had suspected that part for a long time. What they did not know was where the lost material went. It was not completely lost. Something was catching it. Pluto's largest companion is Charon, a battered icy moon about 50 miles wide, locked in a tight gravitational dance with the dwarf planet. Charon has no atmosphere of its own. Its surface is exposed water ice, ancient and heavily cratered, and yet its north and south poles are stained with a strange reddish-brown material, darker than anything else on its surface. For decades, planetary scientists had a suspicion about where that color came from, but they could not prove it. Webb proved it. In a series of studies published in 2024 and 2025, the same international team that confirmed the haze cooling effect also showed that Charon's red poles are made from Pluto's stolen breath. Methane molecules escape from Pluto's atmosphere, drift across the roughly 12,000 miles separating the two worlds, become captured by Charon's gravity, freeze onto its poles, and are then broken apart by sunlight and cosmic rays into heavier organic compounds. The same kind of chemistry that stains Pluto reddish-brown is happening on Charon's face, using material taken directly from Pluto's air. Nothing else in the solar system works quite like this. No other known world is bleeding its atmosphere onto a moon and coloring that moon with what remains. Pluto and Charon are locked in a quiet, slow, almost vampiric exchange that has continued for billions of years. And only now are we beginning to understand it. Webb also saw something else on Charon. In October 2024, a team led by Silvia Protopapa at the Southwest Research Institute confirmed the presence of carbon dioxide and hydrogen peroxide on Charon's surface. Carbon dioxide is the gas you exhale. Hydrogen peroxide is a chemical used as a disinfectant. Both are sitting frozen on a moon billions of miles from Earth, created when radiation breaks apart water ice on the surface and rearranges the pieces. That is the world Webb has been watching, a bleeding planet feeding a chemically altered moon, hidden behind hazes that are slowly cooling the planet further and further. If you could somehow stand on Pluto's surface, this is what you would experience. The sun would still be visible, but only as a sharp point of light. Brighter than any star in Earth's sky, yet smaller than the tip of a pin held at arm's length. It would give no warmth. There would be no glare. You could look straight at it without squinting. The sky around you would settle into a permanent gray-blue gloom, thick with frozen haze. It would not truly be day, and it would not truly be night. It would be an endless twilight that never lifts. The ground beneath your feet would not feel like Earth. Water ice at minus 380 degrees Fahrenheit is not slippery, soft, or glassy. It is rock. Strike it, and it would ring like steel. Swing a sledgehammer against it, and the hammer might bounce back without leaving a mark. Pluto's mountains, built from water ice bedrock and capped with methane snow, are among the hardest terrains in the solar system. If you tried to breathe, the air would not fill your lungs. The atmosphere is about 100,000 times thinner than Earth's. In any practical sense, there is almost nothing there to breathe. But that would be the second thing to kill you, not the first. The first would be the temperature. Exposed skin would freeze faster than it could register pain. Tears would crystallize before falling. Blood would slow, thicken, and stop. And then snow would fall on you. Not water snow. Nitrogen snow. The same nitrogen that makes up most of the air on Earth. The same nitrogen that fills your lungs every time you breathe. It would drift down from the sky and settle on your frozen face like fine white powder. Above you, Charon would hang in the sky and never move. The two bodies are close enough in size that they do not orbit each other the way Earth and the Moon do. Instead, they orbit a point in space between them. They are locked in a slow waltz lasting a little more than 6 Earth days. From Pluto's surface, Charon would always remain in the same place, always showing the same face, suspended overhead like a frozen gray eye that never blinks. And from Charon, Pluto would do the same. Two frozen bodies staring at each other across 12,000 miles, exchanging atoms in absolute silence. Pluto's seasons make all of this even stranger. Its 248-year orbit is so stretched out that for decades at a time, the dwarf planet moves much farther from the sun than it is during other periods. As that distance increases, the temperature drops just enough for nitrogen above the surface to condense and fall as snow. The atmosphere freezes. It falls. It settles as frost on the colder side of the world and waits. Sometimes it waits for a century before the next closer approach to the sun causes it to sublimate back into gas. It is a world that breathes on a 248-year cycle. And right now, it is breathing out. Pluto's surface holds even more secrets than its atmosphere. East of the heart-shaped region, in an area called Tartarus Dorsa, New Horizons photographed something no one had seen anywhere else in the solar system. A field of ice spikes. Rows of jagged blades made of frozen methane. The tallest of them rise as high as 1,500 feet above the ground. They line up in nearly parallel ridges, with gaps of roughly 2 to 3 miles between them. On Earth, similar formations called penitents form in high-altitude deserts and rarely grow taller than a person. But Pluto's blades are dozens of times larger. A 2025 study based on New Horizons data suggests these structures may stretch across around 60% of Pluto's equator, surrounding much of the dwarf planet in a belt of frozen ice. West of the heart, the surface looks burned. A vast dark region called Cthulhu stretches across the equator like a stain. It is reddish-black, ancient, and larger than Alaska. That darkness comes from accumulated tholins, the same organic chemistry that has been raining down from Pluto's haze for 4 billion years. It gathers most heavily where brighter methane and nitrogen ices cannot keep covering the ground. Cthulhu is the part of Pluto that has absorbed the longest exposure to that slow chemical staining. The oldest face of the dwarf planet wears its history like a shroud. And then there are the mountains no one can fully explain. South of Sputnik Planitia, 2 enormous isolated peaks rise from the surrounding landscape. Right Mons stands about 13,000 feet high and around 100 miles wide at its base. Picard Mons, just southeast of it, may rise even higher, possibly close to 20,000 feet, with a footprint large enough to rival Mauna Loa, the largest active volcano on Earth. Both peaks have deep central depressions at their summits, surrounded by concentric fractures. Their flanks are rough, lumpy, and uneven, resembling cooled lava flows on terrestrial volcanoes. They may be cryovolcanoes, not volcanoes that once erupted hot magma, but mountains that may have erupted a cold mixture of water, ammonia, and methane from somewhere deep beneath Pluto's crust. This interpretation is still debated. Some researchers think the entire region may have been reshaped by many vents over long periods, rather than by only a few giant eruptions. But either way, the implication is the same. Something pushed liquid material upward through the ice in Pluto's relatively recent geological past. Pluto, the world we once thought was dead, has a source of heat. Somewhere beneath its frozen shell, it has been warm enough to melt ice and force material to the surface. We do not know when those mountains last erupted. We also do not know whether they might still be active. In the silence around all this, Pluto's smaller moons continue to spin. Nix, Hydra, Kerberos, and Styx are 4 icy bodies named after figures from the underworld. None is larger than about 35 miles across. All of them are trapped in chaotic, unpredictable rotations because the changing gravity between Pluto and Charon never allows them to settle. They tumble end over end, never showing the same face twice in a row. No other moon system we have seen behaves this way. The implications go far beyond chemistry. For most of the 20th century, we thought of the outer solar system as a dead wilderness. Anything beyond Jupiter was assumed to be gas, ice, or rock. Too cold, too distant, and too inactive to be interesting. Pluto was supposed to be the footnote at the end of the textbook. Webb has destroyed that idea. The chemistry happening in Pluto's upper atmosphere is the chemistry of an active world. The organic compounds it is generating are not ancient leftovers from the time of formation. They are being made right now, in real time as sunlight and gas interact in ways that early prebiotic Earth may have once known. Pluto is running a chemistry experiment at the edge of the solar system. And it has been running that experiment for more than 4 billion years without stopping. And beneath all that ice, Pluto may be hiding an ocean. This is one of the most debated ideas in modern planetary science, but the evidence continues to grow. The pattern of cracks and ridges on Pluto's surface is consistent with the possibility of a liquid water ocean trapped below, perhaps about 100 miles down, kept warm by the slow decay of radioactive elements inside Pluto's rocky core. The shape of Sputnik Planitia, the western lobe of the heart, points to a positive gravity anomaly. Something denser appears to be sitting beneath it. Liquid water, denser than the ice above, fits the calculation. If that ocean exists, it may have been there for billions of years. It would be dark. It would be salty. It would be under immense pressure. And it would be one of the most intriguing places in the solar system to search for conditions under which life might exist without direct dependence on a star. A pocket of liquid water, warmed by Pluto's fading internal heat, fed by hydrocarbons drifting down from the surface through cracks in the ice, and sealed away from the universe beneath a shell of frozen rock, harder than anything on Earth. That may be what lies beneath the world we once thought was nothing. We cannot reach it yet. Not now. Perhaps not for a very long time. New Horizons gave us only one flyby. There is no official Pluto orbiter on the books. No lander. No funded mission. The reason is simple. The journey takes a decade. The engineering challenge is enormous. And budgets for outer solar system science have been shrinking for years. For now, Webb is the best tool we have for studying Pluto in fine detail. Every few months, when Pluto returns to a part of the sky Webb can safely observe without overheating its instruments, the telescope turns toward it again and stares. Each observation refines the chemistry. Each one sharpens the model. Each one adds another data point to the question of what is really happening out there. And so far, every observation has made Pluto stranger than it was before. There is one more thing about Pluto, and it is the part that feels most haunting. Pluto is not alone. The Kuiper Belt, a vast donut-shaped ring of icy debris beyond Neptune, contains hundreds of thousands of objects larger than 60 miles across and an estimated trillion comets. Most of them are small. A few are nearly Pluto's size, such as Eris and Makemake. The rest are smaller, scattered through a volume of space hundreds of times larger than the asteroid belt. Beyond the Kuiper belt, the Oort cloud is thought to contain another trillion comet-sized bodies, extending perhaps a quarter of the way to the nearest star. If Pluto is doing these things, other worlds may be doing them too. We are looking at one well-studied example from a population we know exists but can barely see. Webb can observe the brighter ones, the larger objects close enough to reflect a useful amount of sunlight back toward us. The rest are almost invisible. Trillions of frozen worlds, each one potentially performing some version of the slow, silent organic chemistry we see on Pluto. Each one may be hiding an ocean. Each one drifts through the dark with no one watching. The outer solar system is not empty. It is a graveyard so crowded that we cannot count all the bodies, and every one of them may be doing something. When New Horizons flew past Pluto in 2015, the mission's principal investigator, Alan Stern, said the images would haunt him for the rest of his life. He was talking about the beauty. He was talking about the unexpected geology. He was talking about the fact that a world humanity thought was dead turned out to be alive in ways no one could have predicted. Webb has made that haunting permanent. The data keeps coming, and every new batch makes the picture stranger. Pluto is not simply a planet. It is not even merely a dwarf planet in the cold, inert sense that phrase once suggested. It is something else. A frozen chemistry laboratory. A bleeding world feeding a chemically altered moon. A possible water world beneath a shell as cold and hard as stone. A messenger from the trillions of other worlds we cannot yet reach. The universe out there is colder than anything in human experience, darker than any darkness you have ever seen. But it is also busier than we thought. Quietly, slowly, on timescales far beyond human history. It is doing things we are only beginning to understand. Pluto is not a footnote. It is a warning. There is far more happening out there than we ever imagined. And we've only just begun to look.